Today I'm going to review the fluency questions from Equations of a Circle handout from emathinstruction. We'll start with number 1. Each of the following is an equation of a circle. State the circle's center and the radius. In the cases where the radius is not a circle, not an integer, give its value rounded to the nearest tenth. So the first example is x squared plus y squared equals 144. So there are no transformations taking place here because the x is not being added or subtracted by any number, neither is the y. So that means that this circle is centered at the origin. So the center is 0, 0. The radius can be found by taking the square root of 144. The equation of a circle, the format is x minus h squared plus y minus k squared equals the radius squared, where the center is hk and the radius is the square root of r squared. So r squared is 144. So r is the square root of 144, which is 12. So the distance from the center to the edge of the circle is 12 units, and the center of the circle is at the origin. If I had to do a sketch, this would be the edges of the circle. Right? Something like that, where the center is at 0, 0. So in part B, there are translations. The x has subtracting a 3 and the, there should be a y. That's a mistake. And the y is being added by 7. So that means our center is 3, negative 7. It's negative because y minus negative 7 would be y plus 7. So I know that the k is always the opposite sign. And the radius is the square root of 36, which is 6. Part C, the center is going to be negative 5 and negative 1. Because it says plus 5, I know the center is at negative 5, and the y is negative 1 since it says plus 1. And the radius is the square root of 64, which is 8. If you don't know your square roots, let's punch it in the calculator. The center here says minus 2, so positive 2, positive 9. And the radius is the square root of 100, which is 10. Oh, this one looks like part A, where there were no translations. So the center is at 0, 0. And the radius is the square root of 1, which is 1. How do I get rid of this? Oh no. Go away, go away. Oh boy. Ah, there it is. Okay. So this one, the x has not been translated. So the center for the x coordinate is still 0, and the y is -5. It has only been shifted to the left. And the radius is the square root of 25, which is 5. This one, there is no translations, so the center is 0, 0. And the radius is the square root of 50. Now 50 is not a perfect square, and then the instructions, it says to round to the nearest tenth. So we'll get the calculator and round. The square root of 50 is 7.071. So the nearest tenth would be the 0. So rounding means, do I stay at 0 or do I round up to 1? Well, the 7 tells me whether I should stay or round up. Now, is 0.07 closer to 0.10 or is it closer to 0? It's definitely closer to 0.10. So we're going to put, when we round, that the final answer is approximately 7.1. That's the radius. The center here is 3, 0. 3 because we're subtracting 3. That means that the center is moved to the right 3 units. And 0 because the y has not been added or subtracted by an integer. The radius is the square root of 200. 200 is not a perfect square, so we'll put it in the calculator. Square root of 200 is 14 point approximately. That's what the wavy equal sign means. Approximately 14.142. And the 1 is what we have to either stay at 1 or round up to 2. So you ask yourself, is 14 closer to 10 or is it closer to 20? 14, is it closer to 10 or 20? It's closer to 10. So we're going to round this off to 14.10. The center here, you try. Did you say 6, -6? Because that is correct. It's +6 because the x is being subtracted by 6, the opposite, right? And it's negative 6 because the y is being added by 6. And then the radius is the square root of 20. Let's put that in the calculator. The square root of 20 is approximately 4.472. And the number in the tens place is the 4. So this 7 is going to help me determine whether I stay at 4 or round up to 5. So you think, is 47 closer to 40 or closer to 50? Closer to 50. So we're going to round up to 50. So this is approximately 4.5. You can say 50. It's still the same thing. 4.5, 4.50. The 0 just a placeholder. In this case, does not change the value. Which of the following is true about circles whose equation is x plus 5 squared plus y minus 3 squared equals 36? Well, we can find out the center, which will be negative 5, 3, positive 3. And the radius is the square root of 36, which is 6. So let's go see which one of these says what I'm looking for. It's not choice 1. It's either choice 2 or 3. And it's not choice 3 because they have the wrong radius. And this is choice 2. Oh, wait. The diameter of 6. That's not true. The radius is 6. So if the radius is 6, the diameter is 12. But they have 12 pi here. The area is 36 pi. Well, let's see. What's the area of a triangle? I mean, the area of a circle. That's the diameter. The area is pi r squared. And that will give us pi times 6 squared, which is 36 pi. So if the radius is 6, then the area is 36 pi. That's why we have to read, children. Area, diameter, area, circumference. Huh. So the answer is actually not choice 2. The answer is actually choice 3. And then you definitely want to show your work by showing that you got the area, which is 36 pi. Which of the following represents the equation of a circle shown graphed below? Okay, let's check out this circle. What is the radius and what is the center? Because once I know the radius and the center, I could just plug those values in and see which equation works. Because remember, the equation of a circle is x minus h squared plus y minus k squared equals r squared. And the center is hk, and r is the square root of r squared. So the radius, if I just count any distance from the center to the edge, 1, 2, 3, 4. This is 4 units, so r is 4. So that means my r squared is going to be 4 squared. 4 squared is 16. And now, what are the coordinates of the center? Well, this coordinate, the x value is positive 2, and the y value, 3, is negative 3. So the center is 2, negative 3. So I'll plug that in. X minus 2 squared plus y minus negative 3 squared. Well, that can be rewritten as x minus 2 squared plus, so instead of writing y minus negative 3, we can just write y plus 3. Squared equals 16. And now let's check the choices. Is it choice 1, I think? Yep, I think it's choice 1. It's not choice 2 because they added, and the radius is wrong. The radius is 4, but in the equation it's r squared, the radius squared. So it's not choice 2 or 3. In choice 4, they do have the correct r squared, which is 16, but the symbols, the operations, plus and minus, should be switched around. It should be minus 2 and plus 3. So that's wrong. So it's not choice 3 or 4. By completing the square on each of the quadratic expressions, determine the center and the radius of the circle. So we are going to rewrite this equation so that it is in the form x minus h squared plus y minus k squared equals r squared. Then we will determine the center and the radius. So we're going to complete the square. Think of this as the beginning of a trinomial, a perfect square trinomial. And now a trinomial is ax squared plus bx plus c. We don't have a c term. So that's what we're going to get. We're going to determine the c term that will make this a perfect square trinomial. And then we'll determine the c term for the y, which will make it a perfect square trinomial. Ay squared plus by plus c. So we're going to get the c term for each of these pieces. Oh, I keep pressing eraser when I mean to press the highlighter. Okay. We'll do that for the y's. So we have to do it piece by piece, okay? So let's start with the x's. So x squared minus 6x. What's the c term? The formula is b over 2 squared. The b is negative 6 over 2 squared. Negative 6 divided by 2 is -3, and -3 squared is 9. So it's going to be plus 9. And if I add 9 to this side of the equation, I'm going to add 9 to the other side of the equation. Let's do the y's. So here we have y squared plus 10y. We need the c term that will make it a perfect square trinomial. C equals b over 2 squared. The b over for the y's is 10. So it's 10 over 2 squared. 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25. And then we're also going to add 25 to the other side of the equation. All right. So let's rewrite this equation now that we have it as perfect square trinomials. We have x squared minus 6x plus 9 plus y squared plus 10y plus 25 equals, let's add all this up, 66 plus 9 plus 25 is 100. And now we're going to rewrite these perfect squared trinomials as a binomial squared. So what did I square? What binomial did I square to get x squared minus 6x plus 9? Well, I know it has to start with an x. And if I have a 9 here, square root of 9 is 3. And the symbol has to be subtraction because of this minus 6. Negative 6 plus negative 6, negative 3 plus negative 3 is negative 6. And negative 3 squared is positive 9. Now the y, we had to start with a y, and then square root of 25 is 5, and I had to have a plus because 5 plus 5 is 10, and 5 squared is 25. So here's our equation rewritten in a form where we can see in the equation of a circle form, right? So the center is going to be positive 3, negative 5. And the radius is the square root of 100, which is 10. Circles are described below by the coordinates of their centers, C, and 1 point on their circumference, A. Determine an equation for each circle in center radius form. So they're giving us a little bit of information, and we have to use this information to get the equation of the circle. The equation of the circle is x minus h squared plus y minus k squared, which equals r squared. The center is hk, and r is the radius. So they gave us the center. That's great. So we already know that we can plug that in. X minus 5 squared plus y minus 2 squared. I just don't know what my radius is. But I do know that one coordinate on the circle is 11, 10. So this coordinate will help me to find r because I can plug in 11 for the x value and 10 for the y value and simplify that, evaluate it to get r squared. So instead of writing x and y, I'm going to write 11 and 10. 11 is my x, and 10 is my y. I got that from this coordinate. So now let's simplify it. What is 11 minus 5? 6. 6 squared plus, what is 10 minus 2? 8. 8 squared. What is 6 squared? 36. Again, use the calculator if you're not sure what these are. And 8 squared is 64. And 36 plus 64 is 100. So my r squared is 100. So now I can write the equation of the circle. X minus 5 squared plus y minus 2 squared equals 100. Let's do it again for B. Of course, you're going to try it yourself first. Let's change the color. So we're going to substitute the center. That's my H and that's my K. X plus 2 squared plus y plus 5 squared equals r squared. Next, we substitute the values that they gave us. This is my x and this is the y. So wherever I see x, I'm going to put 3. And wherever I see y, I'm going to put negative 17. So 3 plus 2 is 5. So this is going to be 5 squared. And negative 17 plus 5, what was that, 12? Negative 12. Negative 12 squared. 5 squared is 25. And negative 12 squared is 144. So we add these, we'll get 169. So then r squared is 169. Now I can write my equation. X plus 2 squared. I'm just rewriting this, you know? X plus 2 squared plus y plus 5 squared equals 169. The next one, let's use green. So we'll plug in the center. X minus 5 squared plus y plus 1 squared equals r squared. And then we'll plug in the coordinate that is on the circle. Everywhere we see x, we will put negative 2. And where we see y, we will put negative 5. So negative 2 minus 5 is negative 7. And negative 5 plus 1 is negative 4 squared. So negative 7 squared is 49. And negative 4 squared is 16. And 49 plus 16 is 65. So the equation is, and that's our r squared. X minus 5 squared plus y plus 1 squared equals 65. So y'all know I'm human. So if I made a mistake, please say it in the comments, because I made a mistake in the last video and I hope y'all pointed it out in the comments. Solve the following system of equations graphically. So solving a system of equations, that means we have to find the values of x and y that make both equations true. How do we do that graphically? Well, we graph each of the equations and we look to see where they intersect. The points or point where they intersect is the solution. That is the x and the y values that make both equations true, because they intersect at the same point. That means that point fits both equations. If you graph and the graphs do not intersect at all, that means there is no solution. If you graph and one graph fits directly on top, they overlap, everything fits the same exact way, that means that there are infinite solutions. So let's see what we have here. I can tell that this equation is the equation of a circle. It looks like it, The format of the equation tells you what type of equation it is. It has an x squared plus a y squared equals a constant. That's an equation of a circle. Now, what do you think this equation is? Well, this one has x squared, and I believe this one's going to be quadratic. Quadratic. And quadratic makes a parabola. So I'm going to go in my calculator and get a table of values. Y equals 5 minus x squared. And then I'm going to press graph. Get an idea of what this looks like. It's an upside down parabola, just like I thought. Because the coefficient of x squared is negative, I knew we would have an upside down parabola. Because the constant is positive 5, I knew that that's my y-intercept. And that means this parabola has been shifted up 5 units, and the negative coefficient of x squared means it has been reflected downwards. I'm going to press second table to get some coordinates. At -2, at -3, it's -4, at -2, 1, at -1, 4, at 0, 5. Oh, that's the y-intercept, 0, 5. At 1, 4. Oh, here's the symmetry. At -2, 1, and at +3, -4. See, the parabola is going up, and then at 0, 5, it's coming back down. Now this circle, I know the center is at 0, 0, and I know the radius is the square root of 25, which is 5. Let's start graphing. I'll graph the circle first. My center is at 0, 0, and the radius is 5. So that means I'm going to go 5 units in every direction. 1, 2, 3, 4, 5. Up. 1, 2, 3, 4, 5. To the left. 1, 2, 3, 4, 5. And down. 1, 2, 3, 4, 5. And then I make my circle. Oh, my circle's terrible. There we go. Let me make this small. I don't erase the whole thing. Did it just erase the whole thing? It did. That's fine. I needed to do that again. There we go. It's better. Okay, there's my circle. Next, I will graph my parabola. So the coordinates are -3, 1, 2, 3, 1, 2, 3, 4. I wonder if that's a coordinate. Then -2, -1. Then -1, 4. 1, 2, 3, 4. Once I did one side, I already know what the other side looks like because it's a pattern. And then we do the parabola. Something's wrong. -1, 4, -2, 1. This is wrong. Okay. Made a mistake. There's that human thing again. You know what I'm saying? Mistakes are good. Okay? So it's -2, +1, -2, 1. That makes a lot more sense because my parabola was doing some weird thing at the bottom. That doesn't make sense. Correct your mistakes, people. Don't just let it go. You notice something's weird, it probably is weird. You notice something's off, probably is off. Go back and fix it. Okay. So here are my 2 graphs. I'm just not sure about these 2 points, so I'm going to check it. So I know that the parabola's coordinates are correct because I put the equation in the calculator. The only thing I'm not sure about is the coordinates for the circle because this was a sketch, you know? Is the distance from here, the center to this point, actually 5? Or is it just because I sketched it that way, that's how it happens to look? I need to know because if it is, that means it's a solution. And if it's not a solution. And I don't want to get this wrong. So how do I check to see if the coordinate 3, -4 is a solution to the circle? I can just plug it in to the equation. So the equation is x² + y² = 25. If I plug in 3 for x and 4 for y, and I get 25, that means it is a solution. If I don't get 25, it's not a solution. So let's do it. X² will be 3 squared. Y² will be -4 squared. And does it equal 25? Put a little question mark over the equal sign when you're checking. 3 squared is 9. -4 squared is 16. And that does equal 25. So yes, -3, -4, and -3, -4 are both solutions. So we have 3 solutions because there are 3 points that intersect. We have this point, and this point. So what's the solution? the solutions. Oops. I'm writing on nothing. Hold on. The solutions. I'm just going to list the coordinates. 0, 5, -3, -4, and +3, -4. Okay. Oh, only 2 more. This is fun. Okay. Find the intersection of the circle x squared plus y squared equals 29 and y equals x minus 3 algebraically. So just now we solved graphically. Now we're going to solve it algebraically, which means we're just going to do algebra to find the solution. We're not going to graph. But I do want you to think about what type of equations we have here. This is definitely a circle. And what type of equation is y equals x minus 3? It's linear. So if we were to graph it, we would have a circle centered at 0, 0 with the radius of the square root of 29. And we would have another graph, which is a line with a positive slope of 1 and a y-intercept of -3. But we're not doing it graphically. We're going to do it algebraically. So remember what the solution means. It means the x and the y that fits both equations. So if we were doing it graphically, we would look for where these graphs intersect. But since we're doing it algebraically, we want to know where they are equal. Where are they equal? So there are a few methods to solving a system of equations. And this time, I think we should use substitution. Substitution is when you take one equation whose variable, there's a variable by itself, right? And you plug that expression into the other equation and solve. So here we have y by itself. Since y is by itself, I can substitute x minus 3 in place of y in the other equation. Let's do it. So x squared plus y squared equals 29. And I'm going to rewrite this equation, but instead of writing y, I'm going to write x minus 3. So that's going to be x squared plus x minus 3 squared equals 29. And now I have a quadratic equation that I have to solve. Think back to how do you solve quadratic equations? There's also many strategies. But one strategy is you can get it into standard form and factor it, and then use the zero product rule. We could try that. So let's do x minus 3 squared. X minus 3 squared means x minus 3 times x minus 3, right? And that will give us x squared minus 3x plus 9, which is x squared, minus 6x plus 9. And then I'm just going to bring this x squared down. And I'm going to bring my equals 29 down. So now let's simplify this. X squared plus x squared is 2x squared minus 6x plus 9 equals 29. And in standard form, we like the equation to equal 0. So we're going to subtract 29 from both sides of the equation. And we get 2x squared minus 6x minus 20 equals 0. Now I'm going to solve this quadratic equation. This quadratic equation is going to give me 2 solutions, and that's going to be real easy to find the y's that go with the x's. So let's use the box method. You put the first term in the first box, and the last term in the last box and multiply. 2x squared times negative 20 is negative 40x squared. And now I do my product and sum. What two numbers when I multiply I get negative 40, and when I add I get negative 6? Well, to get negative 40, we can use negative 8 times 5. That doesn't work. What about 4? Ooh, 4 and 10. Negative 10 and 4. Yes, negative 4. Negative 10 plus 4 is negative 6. So these are my numbers. This is what I want. Negative 10 and 4. So I put these negative 10x and 4x into the boxes. Now I just have to factor and see what goes out here. What's the GCF of each row and each column? So what can go into 2x squared and 4x? 2x. And then that means I have to have an x here because 2x times x is 2x squared. What's the GCF here? Well, if I have an x here, I have to have negative 10 here. And what goes here, I have to have 2 here. So these are my factors, 2x minus 10 and x plus 2. Equal 0. So you set each factor equal to 0 and then you solve. Well, 2 times 5 minus 10 is 0. So x equals 5. And if x were negative 2, I would get 0. So x equals negative 2. We are almost done. Now I have the x coordinate for my solutions. I just need the y's. I can choose either equation to get the y. It doesn't matter. I'll get the same answer. But for efficiency's sake, I'm going to use the linear equation. Y equals x minus 3. If I plug 5 here, I would get y equals 5 minus 3, which is 2. So the y that goes with this x is y equals 2. If I plugged in negative 2 for x, it would say y equals negative 2 minus 3, which would give me y equals negative 5. So what are my solutions? My solutions are 2 coordinates, 5, 2, and negative 2, negative 5. Okay, application. Oh, I had a lot of space. Where did I squeeze it in there? Okay. Jonas is designing a circular garden whose equation is x squared plus y squared equals 49. He wishes to place a walkway within the garden at all points within the circle that satisfy the inequality y is between negative 2 and 2 inclusive. Graph the circle on the grid to the right and shade in all points that represent the walkway. Well, let's start by graphing the circle, and then we'll figure out what in the world they're talking about with this walkway business. So the graph is centered, the circle is centered at 0, 0, and the radius is 7 because the square root of 49 is 7. So I count 7 units up, down, left, right. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then I put my little my circle as best I can. There you go. Okay, so now this walkway. He wishes to place a walkway within the garden at all points within the circle that satisfy the inequality that y goes from -2 to 2. Graph the circle on the grid to the right and shade in all the points that represent the walkway. Y from -2 to 2. Well, y, where does y equal -2? Let's see. Y equals -2. This is my y-axis here. And y equals +2 here. So where are all the points where y equals -2? Oh, well, that's this line. This is the line y equals -2. And where are all the points where y equals +2? It's all here. And the walkway has to be within these two lines. So let's shade it. Okay, that's a cool garden. I can dig it. All right, I think we're done, everybody.